So in the last unit, we discussed how many different XY pairs can be a solution for a linear equation where you have two variables. And that's what we're continuing with here. So sometimes it can be useful to create a table of values that shows a few different XY pairs that would be solutions for a given equation. And that's because we're going to use these solutions later on in order to graph these equations. So it asks us to complete a table of values for this linear equation here. And so we've been given this equation here where we've been given 5 different x values. So what we want to do is solve for each of those y values by substituting x in. And that's what's been done down here. So for example, here we have when x equals 5. And so they've substituted in a 5 for x, and they end up with a y value of 7. That goes here then, showing that 5 comma 7 is an ordered pair that would be a solution, and so on. So they've done x is 4, x is 3, x is 2, and x is 1. And that allows them to create this table of values, which, like I said, we'll be using in a further unit to then graph a linear equation. So pause the video and give the exercises that follow a try, and then come on back and we can do them together. Okay, so let's look at these exercises here. We've been asked to complete some tables of values. So let's start then with x is 2, and our equation is y is x plus 3. So that would be 2 plus 3, or 5. So we have an ordered pair then at 2 comma 5. When x is 1, we would have y is 1 plus 3, which would be 4. So we also have a solution at 1 comma 4. Okay, x is 0, we'll have y is 0 plus 3, which is just y equals 3. And when x is negative 1, we're going to have y is negative 1 plus 3, which is 2. Okay, next one, same sort of thing. So this time we've been asked to start with x equals 3. So I'm just going to write our equation down again. Okay, so let's substitute in a 3 for x. And we get negative 15 plus 4, which is negative 11. And so that goes up here. Then we have x is 2. So y is going to be negative 5 times 2 plus 4, which is negative 10 plus 4, or negative 6. Okay, x is 1. We would have y is negative 5 times 1 plus 4, which is negative 5 plus 4. Don't forget about your negative there. And that gives you negative 1. And when x is 0, we would have y is negative 5 times 0 plus 4. 0 is nice because that just gets rid of that first number. So we get 0 plus 4, which is 4. And last example here, we're asked to start with x equals 2. And our equation is y is 8 minus 9x. If you want, you could rearrange that to y equals negative 9x plus 8. Either way, I'm just going to leave it as it is. So it'd be 8 minus 9 times 2, which is 8 minus 18, which is negative 10. When x is 1, we would have y is 8 minus 9 times 1, which is just 8 minus 9, so we get negative 1. When x is 0, we would have y is 8 minus 9 times 0, which is just 8 minus 0, or 8. And when x is negative 1, we would have y is 8 minus 9 times negative 1, which is 8 minus negative 9. So that's 8 plus 9. Oops. And so here we get 17.